Hello, this is Schweitzer, and we're here to do a quick little video on the answers to um, our states of matter preliminary quiz. So let's take a look here and see how we're doing. We have a bunch of stuff here, and all of this is looking at types of substances. We have ionic, and we have covalent, often called molecular. I'll grab a little smaller pen. All right. And then, of course, we have network covalent. And hopefully you know the difference between those. All right, so which substance above is molecular? So all non-metals. So CCl4 non-metal. You might even say NH3 would be all non-metals. Metal. Okay, I'm going to say that this is elemental substance, not bonded at all. At least no covalent bonds. This is a two carbon substance, so this might be network covalent, and we might give more information about why that is. But for now, we'll leave it at those two. Which substance is ionic? An ionic bulk crystal. So that's going to be the two ionic compounds, AlCl3. Again, metal and non-metal, and KCl. Which above is a network covalent? That's going to be silicon carbide. And really the only way you know that is it's all carbon families tend to bond 4 times, which can allow this bulk crystal to form involving carbon bonds. And of course we mentioned it in class. That's the main ones. Which substance here is likely to have the highest melting point? Well, that's going to be silicon carbide. In order to melt something, you must break something. Here we're going to break a covalent bond. Unlike here, for this one, we're breaking intermolecular forces, like hydrogen bonding or London dispersion forces. Which substance like this at the lowest melting point? Okay, this is when we're going to break the weakest bond. Only thing holding together helium is London dispersion forces. Which substance is most likely to be a gas? That's going to be helium. That's the one that has the weakest interactions that need to be broken. So even at the lowest temperatures it takes to it can break them easily. Which substance will have a higher melting point? This one or this one? These have the same force. They're both ionic. So now we want to say, okay, of ionic compounds, what are the factors that affect the melting points? And the first one we look at is size of charge. All right, and therefore this one's plus 3 minus 1 plus 1 minus 1. This guy is it right here. All right. Next one. All right. NH3 is room temperature, and therefore liquid can be a liquid. Whereas N2 and H2 are both gases independently. Draw the little structures. So we want to look at, again, intermolecular forces. NH3 looks like this. And you want to go through and be able to draw this out. All right. NH3 has a shape of trigonal pyramidal. It is not symmetrical. Okay. Then we have N2 looks like this. It's symmetrical. And then we have H2 looks like this. And once again, it is also symmetrical. So what about NH3 makes a liquid? Well, we're going to run through the basics of intermolecular forces with both of these. All right, which is our little decision tree, NOF, meaning that do we have a dipole moment? All right, so these guys both have a dipole moment of 0. So this one is nonpolar, and this one is nonpolar. Okay, why? This guy has a stealer, but it's bound to another stealer, so it's got the same electronegativity. So it's got a dipole moment of 0, so it's nonpolar. All right, so over here we have nonpolar. And here, what if we have a stealer right here? Nitrogen is highly electronegative atom bound to hydrogen. So the answer here is yes, we have a dipole moment, a significant dipole moment. And then we go to, is it symmetrical or is it not symmetrical? This guy here is not symmetrical, so no. And this leads us to an unbalanced molecule, which is polar. So if you're nonpolar, the only thing you can use to stick one molecule to another molecule is London dispersion forces. Now this is going to be affected by number of electrons and long chains. Squeeze this in here a little bit. All right, and chains. Either way, if you are polar, then your typical is going to be hydrogen bonding, or just a generic dipole. Let's review quickly the difference between these two. This guy has your stealer hooked to a hydrogen, and there we have it right here. So this steal to a hydrogen makes this a ability to hydrogen bond to another atom. So in this ammonia molecule, why is it a liquid? And the answer here is it is going to hydrogen bond, and that would need to be broken in order to become a gas. So it's hydrogen bonding. It's a little stronger. All right. And the other guys only have London dispersion forces, which is why those guys are gaseous and easy to break. Now, I would expect the to convert to a liquid. N2 will convert to liquid a lot quicker than H2 because it has more electrons. Still quite cold. All right. A local dog's farmer died unexpectedly, and he thought the dog may have been poisoned. The common poison to dogs is ethylene glycol, which is that chemical right there. Note ethylene glycol is commonly used as antifreeze in cars. It is usually sweet taste. Animals can inadvertently drink. What is the percent mass of each element in the compound? All right, so let's do this. We have C2H6O2. I kind of go about just determining the molar mass. So my first step. This is going to be 2 times 12. This is 1 times 6. And this is 2 times 16. All right, so 2 times 12 is, for the carbon, is 24. For the hydrogen, it's going to be 6. And the oxygen is going to be 32. Add those up. 32 plus 6 plus 24 equals 62. So the whole thing weighs 62. And there we go. And then just divide out times 100. So this guy here times 100. So this guy, 24, this is less than half the weight. 24 divided by 62 is 38%. Very small percentage here. 6 divided by 62 is 9.6%. And then 32 divided by 62 is going to be a little more than half, and it is. 51.6, just barely percent. Okay. Next one. A chemist analyzed the animal was found to contain an unusually high concentration of a chemical that is 27.7% carbon and 73.7% oxygen. What would the empirical formula be of this substance? Okay. All right, let's do this. So we have carbon, which is going to be 27.27, and oxygen, which is going to be 73.7%. Okay. Now again, we're going to go from percentage to mass, an actual sample size. All right, so I'm going to use a 100-gram sample size, so just times 100, and this is going to give me 27.27 grams and 73, this pencil's not doing so good, 0.7 grams. All right, then I'm going to convert this guy over to moles. All right, and then, so let's just divide this guy out by 12, which is the molar mass of carbon. Divide this guy out by 16, or 15.99, which is the molar mass of oxygen. Let's do that. So 27.27 divided by 12 gives me 2.27 moles. And then 73.7 divided by 16 equals 4.6 moles. And now this is the moles in my 100-gram sample size. So now I'm going to divide out by the smallest one, which would be divided by 2.27 and 2.27. And I'm going to set my smallest one to 1. So my carbon is 1, and 4.6 divided by 2.27 is pretty darn close to 2, which we were looking for a whole number here, or a half, 2 oxygen. So my empirical formula is CO2. All right. Now, last step. It says the molecular weight of the compound is 88. What's the unknown substance? Do a quick internet search. Is this substance poisonous? Could a dog have actually eaten? So this, of course, is on our quiz, our little practice quiz here. So we could do this if we would like. Either way, my empirical is CO2. All right. Now this guy is the empirical weight is 12 plus 16 times 2 is equal to 32. So this is 44 grams per mole, or AMUs per atom. And we take the molecular weight and we divide this by my empirical weight. And this tells me what multiple I have. This is going to be 88 divided by 44 equals 2. And that means I got to multiply that guy times 2, which is C2O4. And that's my molecular formula, C2O4. Another name for this, minus the charge, is oxalate. Turns out that oxalate is, in fact, if you do a internet search on this thing, you will find that oxalate is, in fact, poisonous and is located in some typical farm garden plants and the leaves of some everyday common plants. So maybe this dog just ate something that it wasn't supposed to out of the garden or somewhere around. Either way, that is the end of our quiz, and thank you very much.